Hello, grade 9 students. We are now in quarter 2 of our subject Mathematics 9. And the first topic is all about variation. So in variation, we're going to discuss its different kinds. So the first one is what we call the direct variation. So before we discuss about direct variation, let us have first this warm up. Number 1, Regina walked 9 miles in 3 hours. How many miles did she walk per hour? What's your answer? 3 miles per hour. So we just divide 9 by 3. So it's 3 miles per hour. Now number 2, to make 3 balls of trail mix, Sandra needs 15 ounces of nuts. How many ounces of nuts does she need for 1 bowl of trail mix? What's your answer? 5 ounces. So again, we divided 15 by 3. Yes, so 15 divided by 3 is 5 ounces. Okay, we have here this problem of the day. Paul has earned $60 from his paper route. Each day, he earns 3.50 more. How many days will it take for Paul's earnings to top $100? The answer is 12 days. How did we get that answer? Maybe we can be able to solve it as we go on with our discussion on direct variation. So in this topic, we will learn to identify, write, and graph an equation of direct variation. And these are the vocabulary we're going to meet along the way: direct variation and constant of variation. So here's now the definition of direct variation. It is a linear relationship between two variables that can be written in the form y equals kx or k equals y over x, where k should not be equal to 0. The fixed number k in a direct variation equation is the constant of variation, right? So remember, the equation is y equals kx, or if we want to solve for k, the constant of variation, we just divide y by x. And remember, k should not be equal to 0. Otherwise, if it's 0, there is no more a direct variation equation. Now, you can read direct variation as y varies directly as x, or y is directly proportional to x, or simply y varies with x. Or it can also be y is proportional to x. So it's the same as directly proportional to x. Let's have here identifying a direct variation from an equation. Tell whether each equation represents a direct variation. If so, identify the constant of variation. Is number 1 a direct variation? Solve the equation for y, subtract 8 from both sides. So it becomes y equals x minus 8. So the equation is not in the form y equals kx. So y plus 8 equals x is not a direct variation. So it must be in the form y equals kx to make it a direct variation. How about this? 3y equals 2x. Is that a direct variation? Let's see. First, let us solve for y by dividing both sides by 3. So y equals 2/3 x. So is this now a direct variation equation? Yes. The equation is in the form y equals kx, so therefore the original equation 3y equals 2x is a direct variation. And yeah, kx, y equals kx, so that means 2/3 is the constant of variation k. Yan yung k. How about this? Y plus 3 equals 3x. Is this equation represents a direct variation? I mean, does this equation represent a direct variation? Let's see. Subtract both sides by 3. The equation is not in the form y equals kx, so it's not a direct variation. And how about 4y equals 3x? Divide both sides by 4. It becomes y equals 3/4 x. I think yes, it's in the form y equals kx, so 4y equals 3x is a direct variation. Now let us also learn how to identify a direct variation from a table. We have here a table. Okay. If it's let us try to identify if this table represents a direct variation. So if so, identify the constant of variation k and write the direct variation equation. So in the table we have the price C 69.99 129, weight in ounce 234. Okay, how can we determine if this table represents a direct variation? First, let us find y over x for each ordered pair, and dapat equal. Y over x is actually the formula for k, yung constant of variation. So if we divide y by x, and they are all equal for each given ordered pair here, then this is a direct variation. So y equals, for the first we have 2 over 69, then what we have 1 over 33, then we have 4 over 129. K is not the same for each ordered pair. The data does not represent a direct variation. Yes. Okay, hindi sila pare-pareho. Yung constant, ibig sabihin yung constant, this means that the constant is not the same for each ordered pair. So dapat equal to make it a direct variation. So in a direct variation where k is positive, when x increases, y also increases. When x decreases, y also decreases. Okay. When x increases in the table, y also increases in the table. That means it is a direct variation. Okay. Let's say here another table. Identify if the set of data represents a direct variation. If so, identify the constant of variation and then write the direct variation equation. So in inches, we have 125, centimeters 2.54, 5.08, 12.70. So in here in the table, as x increases 125, you can see that the centimeters also increases 2.54, 5.08, 12.70. So this is a direct variation. But let us first show that this table or set of data represents a direct variation by solving the constant of variation. The formula for k is y over x. So we'll divide c by inches, centimeter by inches. 2.54 divided by 1, 5.08 divided by 2, 12.70 divided by 5. And you can see there that the constant of variation for each ordered pair are equal. 2.54, 2.54, 2.54. Right? So this means this set of data represents a direct variations. And k is equal to 2.54 for each ordered pair. That's the constant of variation. And what is the equation? Y equals kx, so y equals 2.54x. Yeah. Y equals kx, that's the equation of direct variation, so just substitute k by 2.54. So the equation of variation is y equals 2.54x. Another, price and weight. Price C and weight in pounds. This data, does this data represent direct variation? 5, 10, 15, okay. Increase yung price, increase din yung weight. So, pwede, but let us first solve for y over x. Okay, they are not equal. The constant are not equal, so for each ordered pair, so k is not the same for each ordered pair. This data does not represent a direct variation. About here, meters and miles, 3, 4, 5, 9, 12, 15. Okay, as x increases, y increases. Let us determine the constant of variation, k, y over x. 9 divided by 3, 12 divided by 4, 15 divided by 5, they are all equal to 3. Therefore, this set of data represents a direct variation, where k is equal to 3. That's the constant of variation. And what is now the equation of variation? Y equals kx, so y equals 3x. Here is the equation of variation. Additional example, identifying a direct variation from a graph. Tell whether each graph represents a direct variation. If so, identify the constant of variation. So we have already learned how to identify direct variation from a table. This time, let us learn how to identify direct variation from a graph. Here, we have a graph here, a straight line in the Cartesian plane passing through the origin. Let us see how if this graph represents a direct variation. So the graph is a line through 0, 0, the origin. So this is direct variation. The slope of the line is 1/2. Wait, negative 1/2 should say. Slope is negative 1/2 because the line is going in the left direction. So rise over run, 1/2. That's negative 1 up. So therefore k is also equal to negative 1 up. So therefore the equation is equal to y equals kx, so y equals negative 1 half x. Yeah, okay. So it means to say that the slope of a line is also the constant of variation. So the graph of a direct variation is a straight line. So the graph of direct variation can be compared or is similar or the same to it's the same as the graph of a straight line. And the constant of variation in direct variation is the same as the slope in a linear equation. Alright. So in the direct variation, the slope k represents a constant rate of change. How about here? Tell whether the graph represents a direct variation. Of course, it's a straight line. You just determine the slope. The line does not pass through the origin. This is not a direct variation. O yun. For a direct variation, it must pass through the origin. Okay. If it does not pass through the origin, then it is not a direct variation. Okay, that's the rule, right? This is not a direct variation. A truck travels at a speed of 55 miles per hour. Write a direct variation equation for the distance y the truck travels in x hours. So the distance is equal to rate times time, diba? So distance equal to 55 miles per hour times the number of hours. So let us use the formula y equals kx, where k is 55. X is the number of hours, y is the distance. So y equals 55x is the direct variation equation of the statement number 4. Truck travels at a speed of 55 miles per hour is equivalent to y equals 55x. Another, a truck travels at a speed of 55 miles per hour. Let us grab the data. If the time is 0, then the distance the distance is also 0. If the time is 1 hour here, okay, substitute in the equation y equals 55x. Y equals 55. The ordered pair 155. 2. 55 times is 110. So we have this ordered pair 0, 0, 155 to 110. And if we're going to graph, it forms a straight line passing through the origin. Therefore, it is a it is a graph of a direct variation. Let's check. Y equals 55x in slope-intercept form with slope 55 and b equals 0. Y-intercept should be 0, so that means the line should pass through the origin. So the graph shows a slope of 55 and a y-intercept of 0. Okay. Right. Let's continue. See, how long does it take the truck to travel 660 miles? So find the value of x when y equals 660. So the equation is y equals 55x. So that's the equation of variation. Y equals 55x. So if we're trying to find the time, so x, we're trying to solve for x. Substitute 660 to y, so it becomes 660 equals 55x. Divide both sides by 55. And x equals 12. So it will take 12 hours for the truck to travel 660 miles. Yeah. Okay, another example, number 4a. Bicycle travels at a speed of 12 miles per hour. Write the direct variation equation for the distance y the bike travels in x hours. Distance equals the rate times time, so distance equals to 12 miles per hour times the number of hours. So therefore our equation is y equals 12x. The constant of variation is 12, distance is y, number of hours is x. Now let us try to make a table. and then we're going to graph. So y equals kx. So if x is 0, what will be our y? Substitute in equation of variation. Y equals 12x, 0. If it's y, it's 12. If it's 2, 24. Then we have the coordinates 0, 0, 1, 12, 2, 12. Then let's grab it in a Cartesian plane. It passes through the origin. We have 1, 12, 0, 0, 1, 12, and 2, 24. Connecting the points to form a straight line. So the graph passes through the origin. It's a straight line, therefore it's a graph of a direct variation. Y equals 12x in slope-intercept form with m equals 12 and b equals 0. The graph shows a slope of 12 and a y-intercept of 0. How long does it take the bicycle to travel 96 miles? So from the equation, y equals 12x, substitute y by 96, then divide both sides by 12. 96 divided by 12 is 8. Cancel 12. X equals 8. It will take the bicycle 8 hours to travel 96 miles. So, lesson quizzes. Part 1. Tell whether each of the following represents a direct variation. If so, identify the constant of variation. Number 1, 12y equals 6x. Is that equation 12y equals 6x? Does that equation represent the direct variation statement equation? 12y equals 6x. If we divide both sides by 12, solve for y, then it becomes y equals 6 over 12x. 6 over 12x is 1 half. So yes, it's the direct variation equation where k equals 1 half. How about number 2? Does this table represent a direct variation? Let's see. Let's solve for k by dividing h by the speed. No, 50 divided by 6, not the same as 6 over 50. It's not the same as 7.5 over 40. A cheetah runs a speed of 0.75 miles per minute. Write the direct variation equation for the distance y the cheetah runs in x minutes. So this is the rate. Y equals 0.75x. Y is the distance the cheetah runs. X is the time. Let us now grab the data. Right. This is the graph. If 4, just substitute 4 with x, and then you'll be able to solve for y. 3 4 times 4 is 3. So 4, 3. Tama ba? 3 fourths times 4 is 3. So dapat 3 4, no? 3 4 dyan sana. Well, anyway, 8. How about 8? 8 times 3 fourths, 6. 8, 6. Tama naman. So ba yung 3? 3 fourths times 4. 3 fourths times 3 should say. Pag 4, 3. 4, 3. Yun, tama. Wait, dapat hindi kasi siya naka-sentro sa origin, no? Now, how far does the cheetah run in 5 minutes? So substitute x by 5 times 0.75. It's 3.75 miles. So, how about this? Tell whether the equation represents a direct variation. If so, identify the constant of variation. Y equals 1.5x. Is it A, B, C, or D? Yes, it is in the form y equals kx, where k is 1.5. I think C is the answer. Yes. How about this? Passes through the origin, so it may be a direct variation statement. 10 divided by 2, let's try to solve for the constant. 10 divided by 2, 5. 18 divided by 3, 6. 40 divided by 5, 9. Oh no. The constant of variation are not the same. So I think no. It's not a direct variation. Number 3. An employee's pay is $8.50 per number of hours worked. Write the direct variation equation and the amount y the employee gets in X number of hours. Grab the data. How much does the employee get in 8 hours? A or B? So what will be our equation of variation? Y equals 8.5x. So pareho sila. But the question is, how does this employee get in 8 hours? 8.5 times 8 lang. 8 and a half, 17. 17 over 2 times 8. So 17 times 4. What is 17 times 4? 2. B, I think it's B's answer. Yes, B, $68. That's the end for our lesson on direct variation. See you next time. Goodbye.